And we're back looking at another PicoCTF challenge, this time Wireshark 22222. And the description is, can you find the flag? And then we have a PCAP file here. This is a forensics challenge. So I will open this up in Wireshark. And we'll quickly also look at the hints. First, did you find the real flag, or the flag, and look for traffic that seems suspicious? Alright. As with every time that we open up Wireshark, we're going to do some statistics quickly to get a sense of what we have in front of us. So we'll look first at the capture file properties. We can see it's about 3.5 megabytes, it's 28 seconds of traffic, hardware that it was captured on, not really that interesting. About 5,000 packets captured. Okay. And then let's get a sense of the conversations we have. So this says we have 6 IP conversations, IPv4 conversations. And looks like we have 2 that are overwhelmingly large. 8888, I know, is Google's DNS. I don't know any of these other ones. Okay, so that's something. And then we can also look at the protocol hierarchy just quickly. And if we look at the byte percentage, we can see most of this is happening as HTTP. About 84% of the traffic is HTTP. And it's a lot of MIME multi-part, which means we're sending files across the wire. All right, so knowing that, let's start to take a look. And we'll follow, so we set it to the first TCP stream, and we're going to follow it and take a look at what we have. And it looks to be encrypted. And the way that I can tell is, one, everything looks like gibberish, random characters in this TCP stream. The way to read this, by the way, is red is the initial request from the client, and then you get this slightly blue color that occurs here. That's a response. Then there's another request from the client, and we continue. And you can see Wireshark does a nice job of highlighting as we move through which packets correspond to this. So if we look here, we can see they're doing an exchange of ciphertext, and it's unlikely we'll get anything out of this. So let's continue through onto the next TCP stream. Not much there. Again, we can see encryption's happening, Kerberos. I don't expect to get much of anything out of this one. Let's keep going. More Kerberos encryption. It's a big conversation. Lots of encrypted boundaries happening. Lots of things that look encrypted that I can't figure out. But let's just see if at any point they stop using encryption. Doesn't seem like it. Let's move on to the next stream. Okay, we see we're going to this .57 address. We're doing a get, and we're told this is the official Red's Shrimp and Herring website, and it's still under construction. All right, so that's something. And then we can see we're going back to that 57 IP, and we're doing gets to get the flag. And we get this PicoCTF flag. So let's try that out. The flag is incorrect. Okay, so that's not it. And we had the hint that make sure you have the flag. So let's continue through our streams. We see more encrypted. I'm not going to look at this. I'm going to assume it's all just encrypted. This also looks encrypted. I'll continue through. we see another request to .57, and we see a different flag than what we had originally. This was BFE, whereas this one is BDA. All right, let's try it. Incorrect again. All right, so it seems like when we hit 57, it gives different values for the flag. Here's another one, and we can see same request, and now it's FE8, 711. Yeah, we have a lot of these. So that doesn't seem like it's it. And we could keep going through this. And one of the things we could actually do is, if we thought that this guy, one of these was going to be it, and we didn't want to figure it out, we could script this up to go through every flag that we have and just mechanically do this, so programmatically do this. So as an example, we could apply as a filter for HTTP OKs. So that gets us close. This is close to what we want. What we actually want, though, is let's see. So HTTP IP source, yes, should be that, and HTTP.OK. What we'd like as well. So let's add this on as a filter. So we will include this and select it, meaning we'll add it on. Now we're getting closer to what we want, but we still have these syntax that don't have the Pico flag. So let's see how we can filter even further. I'm just looking for ways to discern this traffic, and one of the ways we could do it is protocol. So let's add on another filter up here, HTTP. All right, and now you can see we just have the flags here, and we want to get these out. So let's take this over to TerminalShark, and I'll show you how I would do this. Again, what we're just trying to do is we're just trying to get each one of these without having to do a copy, a paste. I'm going to open up Visual Studio Code, and we'll create a new file. So here's all I'm trying to do, is I'm just trying to get all these values out, because I think, hey, maybe one of these is the actual file that I need, or is the actual flag that I need. And I want to, instead of running through, let's see how many there are, displayed 90. So there are 90 flags currently shown. I don't want to run through these manually, so I want to script this up. So I'm going through the process of creating a list. What I'm going to do is I'm going to open a terminal, and we're going to use TShark, which is the terminal version of Wireshark. We will do no name resolution, and we'll use the record, which is going to be our packet capture desktop, and then shark. So let's just first look at that. Yeah, so that looks like our full packet capture, and we'll apply a filter with -y, and we'll take the filter that we have right here and bring it over. I really like this workflow, by the way, for going through and using TShark. I like to verify everything using Wireshark, but then you're going to see TShark allows for some nice manipulation of the text, and it'll save us a lot of time. All right, so now we have exactly what we're looking at there, and we want to do an extract of the file, or of the packet contents, and we want to extract, let's see, did we find out what this guy is called? He's called text item. Bear with me, I don't do as much Wireshark as I should. I think maybe it's data-text lines, perhaps. Let's start with HTTP dot. I'm just looking down here, by the way. File underscore data. Let's start with that and see what that gets us. And we will extract it as fields. All right, perfect. So that gave us everything we wanted to take this as a list. And let's save this as potential flags or flag candidates. All right, and then if we wanted to run over doing this repeatedly, what we could do is we could turn on Foxy Proxy and put things through our Burp Suite. And what I'm going to do is I'm going to capture the traffic that happens when I make this request. Let's see. All right, perfect. So I'm going to submit a flag. And then here we can see we're making a post to the API submissions endpoint. And we're passing through the flag that we set for challenge 110. And we will let this continue. So we'll turn intercept off to allow this to go through. And what we can see is we get a response that says correct, false. So we can send this to intruder. And now what we're going to do, we'll clear the positions. And the only position that we want to change is this guy right here. So we'll change this value and we'll make repeated requests. With a payload, we have our simple list that we just set up. Our flag candidates right here. And then we want to look for a value, and that value we'll do a grep match. And it looked like false, I believe. Correct, false. So we'll do a grep on this. And that'll make that a column that comes up in our final result. So we'll start our attack. And you can see we're submitting things. Oh, I screwed up. It's being encoded. Let me stop this. Just to show you, sorry, I should quickly explain what's going on. So here you can see special characters are being encoded in the flag, and that didn't seem to be happening elsewhere. So I'm going to just quickly fix that, and then we can look at this. So I'll discard the attack. I'm going to go under payloads, and you can see at the bottom, payload encoding, URL encode these special characters, and there's our curlies in this list. And we don't want a URL encode because, as we saw here, we're not URL encoding. So let's go back to intruder. Now that we set that properly, let's start the attack again. And I know, because I've already done this, that this will not succeed. So I'm going to pause it at this point, and I'm going to show you what we would look for. Let's make it large. And we can see the area that we were grepping for. The correct is false. And all of these transactions that we sent across, they all had this false value, which means these were not the flag. So we could certainly run through all 80, but I don't want to hammer the site and potentially get logged out. Just to make it explicit, here's a request that we have, here's a response, and we can see that correct is equal to false, but we didn't even have to go into things to check each one of those. You know, normally we would have had to go through each one and look to see that it was false. By doing that grep on the response over here, we get this nice column where we can check. Okay, so that's not where we're going to get the flag. I'm going to discard. We'll go back and we'll look at our PCAP and we'll see what else we have by looking through the protocol hierarchy, and we'll see if anything stands out. And I'm surprised. So obviously, oh, here's why. It's filtered. It's filtered. Okay, let's look again now at the protocol hierarchy. Okay, so we see ARP, but not very much ARP traffic. And then we can see there's actually a lot of DNS packets, 1,500, so about a third of the traffic is DNS. So let's take a look at that by putting DNS up in our menu box. We'll select on that. We'll go to the very top. We'll sort by time. We're making requests against this red shrimp, and herring company. And we're trying a lot of subdomains. We're trying this 1DQO. We're trying it against Google first. So there's Google's a request to Google and a response that says no such name. Here's another one, again to Google. Google responds, no such name. And we keep doing this with different subdomains. Yeah, this is all traffic going to Google. Again, we're just continuing to alter that subdomain at the front of things. I'll just scroll through and see if there's any changes. A good thing to do would be to check and see if any responses actually come back. So are any of these different? Are any of the responses not no such name? The way that we can do that is under the DNS system response. We have these flags. And we have a reply code, no such name. So let's apply this as a filter. And we want to include it on top of our DNS that already exists in the search bar. So we'll do and selected. So now we're seeing all the no such name responses, but what we really want is, we want to see, does anything respond and say, yes, I know this DNS. Let's see. Oh, all right, now we're getting the requests as well, which we don't want, because the requests, obviously, they don't say no such name, and so they fit this standard right now. So let's also remove the queries. Acceptable. So we will filter additionally and not selected. Okay, cool. So there's nothing, none of these DNS requests are actually resolving to anything. So they seem like garbage or something else, but certainly suspicious. So let's take a look at these different domain names. They look like maybe they could be base64 or something like that. So let's do the same filtering that we did to make it easy to grab out and eliminate some of these duplicate requests, because we see things are being spammed over and over again, and it's difficult to read right now. So I'm going to start applying a filter. So we're only looking at one set of these. So for example, I'm going to eliminate the requests related to this win domain. See how we do first? We do the .com, so with 1DQ whatever. Then we do com.west, Amazon. So then we do an Amazon request for it. And then finally we do win domain local. So I want to just grab one of these. And I'm going to do that. All right, response, no such name. So let's get all the requests. We'll add this to our filter. Here we have all the requests, but then we want to further eliminate those other ones, the goofy ones with win domain and everything. So let's see if we can't filter further on the name. And you can see here, I want to show you this, applies filter. It's showing us how it's going to filter, and I don't like the look of that. So let's drill down further and see if we can filter on this. And this looks good. DNS query name equals OK. So and selected. So this is good, but what we're interested in is filtering really for just this. So let's say and can we do ends with? I'm not sure if we have this. I know we can do contains, but unfortunately that's going to include the other ones. All right, so I guess I have to eliminate these instead. That's going to be the right way to do this. So I will eliminate first Amazon AWS. I'm going to say that, and then I'm going to say not. So we want things that are not Amazon AWS. That worked. And that are not win domain. So I will copy this section. All right, and now we're just left with our queries. And we can see we've got a lot of traffic going to Google, and then we've got some traffic going to .57. And it's not much, but it's present. So that also seems interesting to me. So I will add more on IP, and that is destination equals 18.217. I should have just right clicked, but I'm committed now. All right. So this looks to me like base 64, and this is a technique called DNS exfiltration. So if you imagine yourself as a bad guy, there are many ways to transport data off of a system. You could just send it out in big requests that anybody could read. You could encrypt it. You could do many things, but wouldn't it be nice if you could do it in a way that people don't even realize, hey, there's a big chunk of data missing, if you just kind of leaked it out slowly over time by doing DNS queries. And that's what I think we have here. And I think it's happening in the subdomains. I'm going to do a copy quickly, and I am going to open up a base 64 decoder. Oops, I have my proxy on. Turn my proxy off. Let's see if this works out to anything meaningful. It does, PicoCT, so it looks like this is going to be PicoCTF. So I could go through and I could copy and paste each one of these, and it wouldn't be that bad because there aren't that many entries. But let's use TShark again, because it's going to save us a whole bunch of typing, and in larger cases, we would have to use TShark anyway. So I'm going to go back, and I'm going to bring the filter over. And we can see we've gotten it to this point. Right now I could grab this and I could do some matching, but we're going to go even further with some command line magic. And we are going to do an awk to print. Let's see, I almost never get this right, but that looks like not the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, maybe the 11th. Let's try this. So what awk does is it will print out a given column. Well, only if I get the syntax right. There we go. All right, so we got to this column, but what we really want is this column. So let's print out the 12th line. And then we're really, so right now, by default, awk is doing a breakup based off of spaces. So it's deciding what a column is based off spaces. But we can give it another character on which to break things up by using -f. So we'll do an awk -f, and now we'll break up things based on periods. And so we are going to print the very first. I always mess up these awk commands. The format is so goofy. All right, perfect. Now let's do a unique, just to get rid of that last item. Again, I know this is overkill, but if we had thousands of lines, we would have to do something like this. And then finally, we can use translate. And what translate does is it takes a character. In this case, we have new lines that are present that are breaking this up, and it turns it into something else. So in this case, I'm going to turn new line into nothing. Oop. All right, so that doesn't work. So let's try deleting the new line character with a -delete. And there we go. Now we have this stuff that looks like base 64. So if we wanted to continue doing our command line stuff, we could do a base 64 -d to decode. And we've got our flag. Alternatively, you could just bring this over into something like CyberChef if you were more comfortable with that. And you could also, there's no shame in doing a copy and paste or whatever. This is just showing you a pretty slick way to get the flag. And then we'll submit it over here. And that was it. Hopefully that was helpful to you. If it was, you can help me out by liking, subscribing, commenting, doing all that good YouTube stuff. Thanks a lot. Bye.